Our reverse osmosis unit is a Whirlpool model WHAROS5. My son had one just like it, and I decided to get one. It's been installed now about a year and 10 months. There's some things I'd like to point out about this reverse osmosis system. It works good. It doesn't cost much to install one, but you need to know this. This reverse osmosis system has an efficiency rating of 10.63% per the operating manual. That means this is the normal percentage of the influent water, the tap water fed to it, under daily usage. So most goes down the drain as discharge water. Now, if the storage tank is bypassed, reducing the back pressure, the recovery rating is 21.18%, which means under the lowest RO back pressure, you'll still only capture about 1/5 of the water as RO water. This is my opinion. This manual doesn't say this, but if you live where there's a shortage of tap water, you may want to consider a different type of water purification system. We don't have that issue where we live at this time anyway, but I wanted to point that out. Now, the purpose of this video is to test the performance of our reverse osmosis water purification system after nearly 2 years of use on the original filters and RO membrane using a total dissolved solids meter. We're also going to compare the RO water quality to simply boiling tap water. If you're interested in your water quality and you got a reverse osmosis system, you really should watch this. Okay, the purpose of this is to we've got boiled tap water, cooled off, tap water, RO water, and RO discharge water. And the idea is compare these and see what we see with our total dissolved solids meter, and we'll see how that turns out. Our water is relatively clean here compared to some places. We don't have much industrial runoff. We live in the 6 Mile Rural Water District for South Carolina, but they get their water from the Greenville Water System treatment plant on Lake Keowee. The Greenville, South Carolina water system is where we get our water, and that's what we're interested in. They get it from 3 different reservoirs. It shows here 3 different sources: Table Rock Reservoir, North Saluda Reservoir, and Lake Keowee. These are a very good, relatively clean system. So Greenville water is actually a very clean water compared to a lot of city water systems. So we'll take a little closer look at the water quality they produce for us. This is the website for the Greenville water system, Greenville, South Carolina. They've got, generally speaking, the Greenville water system is very high quality water. It's mainly a very clean watershed. They've got, I think, the North Saluda, Table Rock, and Lake Keowee treatment plants. And I believe this one, the Woody Atkins treatment plant, I believe is the one on Lake Keowee, I believe. But they do a couple things to the water. They coagulate it, they mix it with alum to coagulate dirt, form larger particles, and a little bit of sodium hydroxide for pH adjustment. Alum is basically aluminum sulfate, or a mixture of aluminum sulfate and other things. You use sedimentation or dissolved air flotation, and that helps get particles out of it. And then filtration is made through fine materials like sand or coal. Coal, now that's surprising. These layers stop even the smallest particles, contaminants getting through. This is what I'm really interested in, disinfection. Some water treatment systems use straight chlorine. Some use a mixture of chlorine and ammonia, as this one does, to make basically chloramines in the water. That helps. It's a little longer lasting in the water. But it can present an issue for the reverse osmosis system. So let's look here. They do add fluoride to it, and I'm not going to comment on that. There's a water quality report here, but they're talking about pink rings, and we're not interested in that for this. PFAs, it's basically perfluoro. Well, they call it for per and polyfluoroalkoxy substances, or PFAs. It says in 2014 none were detected, and then they tested again, and really none of it was found. So, which is a good thing. We don't have that issue. But what about the monochloramine and reverse osmosis? Let's see what it says about that. Chloramines. See, it's added It's actually created in the water when ammonia is added to chlorinated water. And they talk about it being 3 different substances: monochloramine, dichloramine, and trichloramine. The water industry relies on monochloramine as a disinfectant. So that's what we have in this water here. It says here when they start using it, since the 1930s actually. Do other water systems use it? Yes. Why do we need to add a disinfectant as a safeguard to waterborne illnesses? So that keeps us from getting typhoid and all these other things. Why does the Greenville water system use chloramine? It's more stable than free chlorine. This allows the water to maintain its disinfectant residual throughout the distribution system. Why are chloramines removed prior to dialysis? That can harm the kidney dialysis patients during the dialysis process. And what effect does chloramine have on rubber? It says it may disintegrate rubber over a period of time, which obviously that's not good. How can I remove the chloramines from my water? Chloramine, this is what I wanted to point out, cannot be removed from water by boiling, distilling, or reverse osmosis. That was a new one to me. I did not know that. I assumed the reverse osmosis would get everything out. But it says the best method and recommended by the US EPA is an activated carbon block system. The cost will depend on the type of system purchased, whole house versus one attached to a water spigot. And another option is for those not wanting to bathe in it, is add some vitamin C to your bath water, which is interesting. But so for our standpoint, the Whirlpool reverse osmosis system I have has 3 filters associated. The first one is a pre-filter, is for sediment, and I think it does have activated carbon in it. So, which is good because that should remove the chloramine before it gets to the RO membrane. Okay, I'm going to ask Microsoft Copilot what it thinks about reverse osmosis and monochloramine. Let's get it started here.
Scott, you're back. How's your afternoon?
Good. I got to repeat myself and ask you the same question I asked you a minute ago. Our reverse osmosis system has a pre-filter, an RO membrane, and a post-filter. And our water is treated water from the Greenville water system, and it has monochloramine in it. How effective will that reverse osmosis system be at removing the monochloramine? And could monochloramine damage the RO membrane?
Reverse osmosis systems are quite effective at removing monochloramine, but it depends on the membrane and maintenance. However, long-term exposure to monochloramine can degrade the membrane, so regular checks and pre-treatment options are recommended.
So is it the pre-filter with activated carbon in it that's necessary to protect the RO membrane from monochloramine?
Yep, an activated carbon pre-filter is crucial. It reduces monochloramine levels, protecting the RO membrane from damage. Regular maintenance of this filter is key.
Okay. I had delayed changing it for almost 2 years, so it's not a good idea, it sounds like it. I need to change it more often.
Yeah, 2 years is a long stretch for a pre-filter. Swapping it out regularly keeps your RO system running efficiently and ensures better water quality. Good call.
Okay, thanks. Okay, I'm going to collect some cold tap water to boil. Don't want to use hot water because maybe some residual scale or something in the hot water tank could affect these results. So I just want to use regular cold tap water and then boil that. Okay, we're losing a lot of water vapor. Now what that will do, boiling it will drive off any volatile materials in there that have a lower boiling point than water, because it can't get any hotter than the boiling point of water as long as it's boiling. So basically any non-volatile stuff will probably concentrate. It could get a higher total dissolved solids rating, but we'll see. We're going to finish this. We got about 27 seconds left, and then we'll let it cool to room temperature, compare it. Cover it, keep any contaminants from getting in it. I guess some just plain tap water and let it set out in 12 to room temperature like we're doing with the boiled water. That's probably enough. This is our RO unit under the sink here. Top cartridge is pre-filter, membrane, and post-filter. Got some activated carbon, filters any sediment, and some other things. Could also get some monochloramine. That's the main deal there, the RO membrane. It gets out most of the contaminants. And a post-filter really for taste. Okay, this is going to be our RO water. Okay, this is the RO unit. Our RO discharge water is coming down from this tube right here. Normally it would just go down the drain. I put this T in here to capture it, takes it down under the house. I had an indoor garden in the basement until it got too cool down there to grow, but I'm going to go under the house to capture that discharge water. Okay, this is where I get my RO discharge water out. It's been a while since I've opened this up, so I'm going to let that flush out. Of course, the RO unit has to be working to get discharge water, so I left the RO faucet on upstairs. We'll let this run for a little bit. It's coming down. You can see it coming through the pipe. That's probably pretty well flushed out that line, so I'm going to go ahead and collect some. Now, this discharge water should be slightly concentrated over the tap water, but since these things are actually fairly inefficient, you lose several gallons of water down the drain for every gallon of reverse osmosis water you produce, the produce water. Since we don't have a water shortage around here, it's not an issue, but for those of you living in areas where you do, you want to do something different. Now, I did have a garden down here. I don't now, as you can see. But this hybrid heat pump hot water heater we have is like a refrigeration unit. It was keeping it too cool, so I just decided to heck with the garden down here. Okay, our boiled tap water here was cooled off the room temperature. That is plain tap water. This is RO water. This is RO discharge water. This is store-bought distilled water from the local Ingles grocery store. So the first thing I'm going to do is use my TDS meter, total dissolved solids, to check the distilled water. Okay, we're at 0. Okay, let's put that in there. You can see it's reading 0. Really nothing in it that can really measure. Okay, since that's distilled water, I don't need to worry about rinsing it off. We'll put it in the boiled tap water. Okay, we're reading, if you can see that, 29. Okay, I do need to rinse this off. Okay, I rinsed it off and cleared it. Let's see, we're going into the plain tap water, hasn't been boiled. 20. Okay. We do need to rinse this off. Okay, it's important to note that the tap water had a total dissolved solids reading of 20 and the boiled tap water was 29. This indicated that ionized dissolved substances in the water were not removed by boiling and were concentrated by the evaporation of water. I rinsed it off distilled water, cleared the reading, and we'll go into the RO water. We're reading 2. So definite, significant difference, you can see that, between the tap water, the boiled tap water, and this. This is the RO water. We'll rinse this off. Now we'll measure the RO discharge water. Measuring 20. About the same as the tap water, which really you would expect because it's very diluted. This is the pre-filter cartridge, and this is the RO membrane here, the middle one, then a post-filter cartridge, really for taste. I got this set of the pre-filter and post-filter replacements from Amazon. I bought the original unit from Amazon. It's easy to get. None of this stuff is real cheap, but it's not super expensive either. But just depends on how bad you want to ensure you got good water quality. So Anyway, I may do a video on replacing these. I don't think it's too hard to do. The main thing I want to do is find out whether or not after a year and 8 months without changing any filters, if this unit was still effective. We went from 20 for total dissolved solids on the regular tap water down to 2 for the RO water. So that's pretty effective, I think. Of course, you don't know exactly what it's removing, but since some things might be removed by the activated carbon filter, the pre-filter, I said it does make sense to go ahead and replace those pre and post filters. And the RO membrane is probably still good. Looks like it is to me. So, hope you enjoyed this. If you did, please like the video and subscribe. We'd really appreciate it. Thank you.